Hello students, welcome back to a new video lecture on shock waves. So first of all, let us see what is a Mach number. Mach number is defined as the ratio of speed of object through a fluid to the speed of sound in the fluid. So in simple you can write it as Mach number. It's defined as generally designated by m, that's equal to object speed through fluid speed of sound in fluid. So simply you can write it as V by A. So what exactly this? So basically, you are finding out ratio of object through speed through fluid, the speed of sound in that fluid, or you are representing velocity of the object in terms of velocity of sound. So of course speed of your sound you know. So before going to shock waves, let us recall whatever the basic aspects we have studied, that is distinguish between acoustics, ultrasonic, subsonic, supersonic, etc. Okay, so let us see the distinction between acoustic, ultrasonic, subsonic and supersonic. So acoustic waves are classified on two different ways. An acoustic wave is a simply sound wave. You simply say sound wave. It moves with the speed of 333 meter per second in air at standard temperature and pressure. So it has a frequency 20 Hertz to 20 kilohertz. This is known as human audible region. Amplitude of acoustic wave is very small. Okay, so then there is one speed remains same, there is no change in speed, but frequency above 20 kilohertz is known as ultrasonic wave. That is about 20 kilohertz. If it is below 20 hertz, there is one more classification, not be so important. It's known as infrasonic. So this is a classification based on frequency. Now there is a classification based on velocity. So the first classification is subsonic wave. Here the speed of the body or mechanical wave in the fluid is lesser than that of sound. So in particular medium or fluid, the velocity is lesser than sound. The speed is referred as subsonic. Sonic means sound, so subsonic, less than the sound. That's what exactly the meaning. So if you just see how exactly, okay, I will switch over to how exactly it comes. So if there is an object, let us say there is a object, okay, so sound wave will be faster than the velocity of V is less than E. Velocity of the object is less than velocity of sound. Sound wave will be expanding something like this. So sound wave is expanding forward. So expanding waves are forward. So you can hear sound first, then you can see the object. Okay. So the range is the Mach number range is between subsonic, means it is 0.3 to 0.8 is known as. So Mach number, that's velocity. So 0.3 to 0.8 Mach is a subsonic wave. Okay. Next, let us see another classification that is known as supersonic. Another classification. So supersonic wave. Here, supersonic wave, the Mach number is between 1.2 to 5 Mach. So here the velocity of the object is more than that of the sound. So if you consider a object, okay, all cruise missile, superjet can travel with this velocity. So object is ahead, sound is expanding backward. Okay, something like this. So this angle is known as mu, that is Mach angle. Okay, V is greater than E. So wave is expanding backward. You can see here sound, later you can see the object first. Okay, so the common angle between common tangent drawn to the expanding wave, which makes angle, that is known as, this cone is known as Mach cone and angle is known as Mach angle. Of course, Mach angle is given by mu is equal to sine inverse of 1 by m. So if you know what is a velocity, so then you can find out. Okay, if Mach number is more than or equal to 5, then it is known as hypersonic wave. So there is one more classification in between we have left with, that is between 0.8 to 1.2. This range is known as transonic. This is a very important range. That is, transition takes place from subsonic to supersonic. Here when m is equal to 1, very important thing happens. So that is, object is traveling with the velocity of sound. So then you can see expanding wave is something like this. So object is moving with the sound wave. So you find a very high pressure is built up at the nose of the object. This is what exactly happened during the Second World War time. Whenever pilot of the fighter jet trying to move with the velocity of sound, fighter jet used to collapse. That's because of this very high pressure developed. But of course, that happened because of the weak engine they had in their fighter jet. But nowadays there are fighter jets so that can travel more than the velocity of sound, which can travel with the velocity something like 3.2 Mach, something like that. Next, let us see what is shock wave. What exactly? Shock wave. Okay, shock waves. Okay. So any fluid that propagates at supersonic speed give rise to a shock wave. Shock waves are produced in nature during earthquake, that's known as seismic waves, which travel with the speed ranging from 2 km per second to 8 km per second, very high speed. Sometimes lightning strikes the earth through shock wave itself cannot be heard, though shock waves cannot be heard itself, but we can hear a sound as the velocity of body increases from subsonic to supersonic. That is known as sonic boom. A sound produced when body changes its velocity from subsonic to supersonic. So during this process it produces shock wave. Shock wave can be produced by sudden dissipation of mechanical energy in medium enclosed in a small space. Okay, so there are its properties of shock wave. So first one, properties. First one is they always travel in a medium with Mach number exceeding 1. M is greater than 1. So shock waves obeys fluid dynamics, laws of fluid dynamics. Okay. The effect caused by shock wave results in increase of entropy. So there will be entropy change, okay, disorder. Okay. Across the shock wave, supersonic flow is deaccelerated into subsonic flow. This process occurs adiabatically. Then shock wave exists in medium propagated confined to a very thin space, thickness not exceeding 1 micrometer, within which the medium subjected to increase in pressure, temperature and density. So that means shock wave exists in a very confined region that's known as control volume. Okay, so control volume is a model on the basis which shock waves are analyzed. It is an imaginary thin envelope, say imaginary thin envelope that surrounds shock front, with which there is a sharp increase in pressure and temperature and density in the compressed medium. Consider two regions, pre and post. Then okay, front, okay, post shock side, let rho 1, P1, T1, H1. Okay, this is a pre-shock side, pre-shock. This is post-shock. Here density change, let us say rho 2, pressure let us say P2, and temperature let us say T2, enthalpy let us say H2. So here M1 is greater than 1, pre-shock, M2 is less than 1, post-shock. So it's like a packet. So this small envelope is known as control volume. It is assumed within this volume heat energy is constant. Okay. So let us see basic conservation laws which you have studied and forgotten. So there are three basic laws of conservation laws. The first law says, a law of conservation of mass, This law says the total mass of any isolated system remains unchanged and is independent of any chemical and physical changes that could occur within the system. Simply you can write rho u1 is equal to rho u2. So this is called as concerning conservation of mass, where u1 is the velocity of fluid ahead of shock, and u2 is the velocity following the shock. Okay. Next is law of conservation of momentum. So in a closed system, total momentum remains constant. That's what exactly law of conservation of momentum says. Total momentum remains constant in a closed system. That can be represented mathematically as P1 plus rho U1 square, that's equal to P2 plus rho U2 square. Of course, all symbols have common meaning. P1 is a pressure before pre-shock and P2 is a pressure post-shock. Okay. The third law is law of conservation of energy. The total energy of a closed system remains constant and is independent of any changes occurring within the system. That can be represented mathematically as H2 plus U2 square divided by 2. This is conservation of energy. Next, let us see how exactly to produce the shock wave, that is a ready tube. It's also known as a ready shock tube. So called as shock tube. Simply it's called as shock tube. So ready tube is a hand operated shock tube capable of producing shock wave by using human energy. So let us see how exactly construction of this is done. So there is a 1 meter long steel tube, 100 centimeters its length. So this tube is divided exactly to half at 50 centimeter, two section. In the first section it is fixed with a piston. This is known as driver section. This is filled with the driver gas. The other section is known as a driven section. This is filled with the test gas. Okay. This is separated by a thin layer of aluminium or paper diaphragm of thickness 0.1 mm diaphragm. Generally it is made from aluminium or paper, etc. Okay. So the driven section is fixed with a pressure sensor to measure the pressure, and driven section is also fixed with two sensors with a fixed distance. Roughly it is fixed at 70 and 80 centimeter. So separation of the sensor is also fixed. So this end is known as upstream end, this downstream end. This is downstream end, and this will be upstream end. So now what is done? This is a total construction. Okay. So these sensors are made from the piezoelectric material, which converts mechanical energy into electrical signal. These sensors are connected to oscilloscope. Okay. How exactly it works? So Now this piston is pushed, so driven section is gas is compressed by pushing the piston hard onto the driver tube until diaphragm ruptures. Following the rupture, driver gas rushes into the driver section and pushes the driven gas towards the far end stream, and this generated moving shock wave transfers the length of the driven section, and shock wave instantly rises the temperature and pressure driven gas as the shock wave moves over it. Of course, the propagating primary shock wave is reflected back at the downstream, and after the reflection test gas undergoes further compression which boosts its temperature and pressure still higher value by reflected shock wave. This state is of high value of pressure and temperature sustained at the downstream end until expansion of wave reflected from upstream end of the driver tube whereas the neutralizes compression partially. So important thing is during a primary shock wave, when it reaches S1, this will give the signal, then it reaches S2, that will give the signal. From this you can measure the time difference to travel this distance. This distance is known distance, so from that you can find out the speed. Of course, from that you can measure the Mach number. That's what exactly role of oscilloscope. So what are the characteristics of this reduced tube? Reduced tube, of course, operated with hand operated. So shock producing device. It is capable of producing Mach number exceeding it, M will be greater than 1.5. Of course, rupture pressure is a function of thickness, that is very obvious. So it produces temperature exceeding more than 900 Kelvin. T is more than 900 Kelvin. So it's easy using helium or argon gas. Of course, other methods of creating shock wave is using, of course, ready tube is one, detonation, very high pressure gas cylinder, and combustion, etc. So finally, let us see some applications of shock wave. Of course, first application is cell information. So this is a genetic engineering application. By passing shock wave, appropriate strength of DNA can be pushed into cell. So if we can push the amount of DNA required using shock wave without damaging cell, that is a specialty. The second one is wood preservation. So by using shock wave, chemical preservatives in the form of solution could be pushed into interior of the wood. This makes process of introduction of preservative into the wood much faster, more efficient. That is a speciality of wood preservation. Then of course kidney stone removal, stone treatment. Of course, nowadays for kidney stone treatment, laser is used. Shock wave is used to shatter the kidney stone into smaller fragments, after which they passed out body smoothly through the urinary tract. So there is no surgery, just you are passing a shock wave that shatters the kidney stone into smaller pieces. So if you are using laser, a small hole has to be made to pass the laser, but here that also not required. Shockwave assisted needless shockwave assisted it's not needless, needleless drug delivery. What exactly this? By using shockwave, drugs can be injected into body without using needles. So without using needle, drugs can be injected. That is, taking a capsule of medicine, above which that is placed on the skin body, and above which a shock tube gun is placed and shock wave is produced that will push the drug into the body through the pores of the skin. So therefore there will not be any pricking pain. Finally, one more uh, application in pencil industry. So in modern process using shockwave, wood is placed in a liquid and shockwave is sent through. The liquid gets the wood into almost instantaneously. The wood then taken out and require no long time drying. So this is a very easy to process the wood in the pencil industry. So more detail can be referred in the Chinto Kumar book. Very detailed application and everything is given. So here for examination point of view only brief description is required. So with this we have completed this module. So thank you for watching.